if you distribute the bars evenly, so if you're saying if you take some of these 18s and distribute some of that down to the 6, oh, let's get to him. So take like 4 off of this, put it here. Take some more off of this, put it here, and keep shoveling it out. It's going to average to 4.6, which is what, 34 divided by 4, yes? If that's right. 34 divided by 4?
I got 18 and a half. 18 and a half.
18 and a half.
Well, there's 18 and a half lines, you know, chunks.
18.
From 16 to 18, that one piece, there's 8.
Could just be one.
6, 20. Now I'm confused here for a second. I think I confused myself.
I wasn't counting.
That's 35 in here. I just realized it's nothing under 34.
I was counting by 2s, because I just counted each.
I've got a slight goof in here somewhere. The data's pulling from the wrong set, maybe. Let me check something real quick. I want to make sure this matches our data perfectly, and it doesn't right now, and that bugs me. Hang on. Key document. Here is your data right there. There's 34, early grouped. Early grouped. Why is that summing to 35? You know what? Let it go. It's close enough. I don't know why that's 35 and not 34 unless
Are you counting 0 as a number?
I should be, because there was one person who had 0 keys. I'm not counting zeros, I'm counting the one person who had 0 as a number.
Okay.
Does that make sense?
Yeah, no, I was just wondering if the
No, that's a good point. But here there are 34.
35. There's 35.
No, there's 34 right here. See it down here? Because there's the label is in the first spot.
Oh.
So it's 34 here. And now what I'm curious about is why B3. Maybe that's what it is. B3. Hang on one second, guys. Thank you for satisfying my annoying. Oh, to hell with it. No, I'm not going to mess with this now because I'm going to make it worse. I'm going to make it worse. I'm going to. No, hell with it. No, stop. We're using those numbers. We're using these numbers because it won't be off that much. Crap, I'll fix it later. Look, go back to what you were saying, Rob. If you take those and spread the bars evenly, is that the same as we did with lollipops? Is it? Well, it's the same in that we're sharing something, but are we sharing the same things?
No, sure.
We're not sharing that. When we were sharing the lollipops, we were sharing the values that were down here. Lollipops would have been down here, yes?
Yes.
If we're sharing the frequencies, we're sharing not the data, but how many times the data occurs. So in other words, if you share the frequencies, you make it look like there were just as many zeros as 1s, as 2s, as 3s, as 4s, as 5s, as 6s, as 7s, as 8s. But that's not what happened. We don't want that to occur. We don't want to make it seem like there were just as many people with no keys as 4 keys as 9 keys. We want to find out in this distribution of values, what's the shared amount of keys. You see the nuance of what I'm saying there?
So would the lollipop be more like population sample and this is more like a sample average?
We're going to treat them all as sample averages.
Okay.
But the thing I need to do is, I need to somehow, looking back over to my calculation over there, looking back over to my calculation right there, that summation of x, I want to know how to get, I know that n, well according to this is 35, damn it, that drives me nuts now. But I know the summation of x is a value. Can I get a corresponding summation of x from this graph? For example, can I get how many total keys there are from
I keep
this?
getting 33 from that.
Yeah, me too.
6, 18, 8, and then 1.
Yeah.
That's 33, not 35. Okay, somebody said 35, I went with that.
It's still wrong.
And I know why now. I know why. That thing wasn't adding in. This should actually be 7.
It wasn't adding 0.
It wasn't adding the 0 because it was B3, not B2. Is that what you were asking about?
That's what I was saying.
Oh, dude, I'm sorry. I'm sorry. I thought your question was, should we not add the 0 person?
No.
No, it's a person, but the code wasn't grabbing it.
Yeah,
It was
that's
set
what
to
I was
B3
saying.
and not B2. Sorry, brother. So this should actually be 1 bar taller.
Yeah.
But That doesn't change our median or our mode at all. The same cross-offs are still going to happen. But let's use that correct data point now. Let's use that correct data point. Can we get from these bars how many total keys there are in the room, approximately? For example, how many total keys are in this bar right here? Say that again.
You can't.
There are 7 people. Remember what this is? This is the number of people that have those keys.
But you don't know.
So
how many
7,
have
you
two
don't
or
know how many keys each individual one has. That is a problem. You don't know how many had 0, how many have 1, how many have 2. So what should we say they all have?
1.
Let's stick with our gut that we've been using ever since and say that these people have 1 key, these people have 4 keys, and these people have 7, and these people have 10. Now, that's of course not correct. That's of course not correct for every single person. That's not correct for every single person. But that's okay. Watch what happens as we put all our results together. I'm going to keep track of this in a table because it's going to get kind of confusing in a minute. I'm going to put x equals the number of keys per group. Or per, you know what, let's use the correct term, per class. And we know that it's either 1 or 4 or 7 or 10. That's the first class, the second class, the third class, and the fourth class. Not first class like first class flying, but just the classes we've broken the data into. No matter how wide your class is, just pick the middle value every time. That's the simplest way to minimize error. What's the frequency for each of those? So the frequency for the 1 is the 7. That's how many people had that 1 key. How many people had 4 keys?
18.
That's where your 18 is. How many folks had 7 keys? That's 8. And how many folks had 10 keys? That's just the 1. How is this going to help us figure out how many keys total we had in the entire room?
Because now we can use the formula
What formula? On what? On what, Sarah?
to get the X bar.
Good. What formula do you want to use?
The one with the Greek symbol.
Good. Tell me how we're going to use it. What are you going to add up?
You're going to add up the frequencies and divide it by the,
By 4?
no, by the total.
No, by 4. By what total?
People.
That's 34, right? According to this, that should be, hopefully it's 34 now, because of damn math. Good, it's 34. Thank you, Cody.
Yep.
So, but the problem with that is if I sum up the frequencies and divide by 34, I'm going to get 1. Because the frequencies sum up to 34. Right? This right here, the summation of the frequencies is 34.
Would you add up the number per
Wait a minute, Rob, say that again.
Multiply the 1 and 7 and the 4 and 8.
Why would I do that? So you're saying do this? You're saying make an XF column. 1 times 7 is 7. 4 times 18 is 72. Check my math on this. 56. 10. What's that?
The total number of keys.
In each class. Thank you, sir. So that means there are 7 keys held by these 7 people. There are 72 keys held by these 18 people. There are 56 keys held by this 8 people. And there are 10 keys held by this 1 person. Now we know it's not going to be exact because JT, you had 9, not 10. So I've overestimated you, correct? But chances are I underestimated somebody else somewhere else. So now I think we're going to have a ballpark for how many keys were in the room by adding this guy up, yes? So Sarah, yes, I agree. We can use a formula at this point. I totally agree, but that's what we want to add up, yeah? Good. So let's scroll over here to get this average. Ba-doom-da-doom-da-doo. So for our average, let's sum up that XF column and divide that by the 34, the end value of 34. So what do we get? Let's see what we get.
4.2. 4.36.
I'm sorry, you guys are ahead of me. I was past the adding. So 78,
145 keys.
145 keys?
We lost 3 keys.
We lost 3 keys over 148. That is not bad, is it?
No.
145 out of 34, which is going to lower our average a smidge, about 4.4, I'm guessing? Oh, 4.3, there we go. 4.3, so we lost a couple tenths of a key on average. We knew it wasn't going to be exact. My amazement is, look how damn close it is. That's what blows me away. Even though we've lost we've lost that exactness that we had over there. We're still able to pull a meaningful average from that if we just know how to deal with that data collected in the way it's dealt. You're not as excited as I am, that's okay. Lydia, go ahead.
No, actually, when we actually did the problem, it actually came out as like 4.3443. So that's just.
Oh, I heard differently. I'm sorry. I heard it was 4.46 or something like
That
that.
was 4.4.
Okay, so it's 4.4, so it's even closer. I was happy with 0.2 off. I'm even happy with 0.1 off. Oh, go ahead.
Well, the beginning average.
The beginning average was closer to 4.4, I'm being told.
Okay.
I heard wrong. I heard it was closer to 4.5. I'm even happier now. 4.35, holy crap!
So that's what I got you.
Yeah, without-
Yeah.
My head's gonna explode. Stop now! The point is this, though. The point is this. Look how close we get to the actual.
So we're only about 10 off.
Exactly. Well, or a couple hundredths off. Yeah, half of a hundredth. This is what's amazing. This is what's amazing about even without the raw data, you can still get a reasonable estimate for all of the measures of set that you need. The good news is you're almost never going to have the raw data. So you have these tools. That's the beauty of it. You almost never have raw data in your lives. You're given displays like this. Let me pull this down. This is messy. This is what the historical data actually looks like. You guys were part of this. So Cody, when you laughed about the whatever it was, the 12 before, I actually had a student that had 27 one year. I heard it when he pulled it out of his pocket. It was like a warden in the back. It was great. I love leaving him in there because I forget his name now. It was I had class in Boyle, the big auditorium in Boyle. I heard him back there. What the hell is that back there? But notice how similar your guys' graph, looks to that, if you will, population graph. So Sarah, here's your population versus sample. This, if you will, is the population, historical population. And here's your sample. It's pretty close. It's pretty close. You've got this kind of heavy, it looks like 0 to 5 is the most, then it just kind of tails off after that. Kind of a cool exponential distribution. Fun, huh? Now, the point of this, the point that you guys just did, this last computation that we just walked through, is a very specific kind of mean that you guys have to be able to deal with on a daily basis. I think we have enough time to do one more of these. I want to make sure you understand the type of mean you just did here versus the type of mean of adding up and dividing by. Everybody knows how to do this coming into a stat class. They learn it. Do you remember when you learned it? I'm guessing it was like 4th or 5th grade. As soon as kids learn how to divide, teachers love teaching kids how to do averages. Fantastic. I love that. I love that because once you know how to divide, it's like, holy crap, and they know how to add already. We can do an average. That's totally awesome. The problem is you shouldn't always do an average. We'll go more to that on Thursday. But what I want to do now is I want to talk more about this particular kind of average where the data is not equally spread from class to class. This was your data right here. This was your data right here. So when the data is not evenly spread from class to class to class, you got to be careful to make sure you account for the different frequencies. So Rob, I love what you said earlier about chopping the tops off and kind of staggering them across. The problem with doing that is you get a kind of a misleading result because you've now made things too low and too high. You're pretending there are more people with more keys and you're pretending there are more people with fewer keys than there actually were. So you can't change this graph, but you have to be able to always deal with data in this kind of a form. And this is called, does anybody know what kind of average this is? When you have data that has frequencies attached to it, it starts with a W. You may have learned this before.